Consider the straight line L in the Cartesian plane with equation 2x plus y equals 10. That's this line shown here, 2x plus y equals 10. We have to determine a vector equation for this line. To do so, we need to know a single point on the line, and in fact there's one here and one here that we can choose. And then we need to know the direction vector of the line, the direction vector b that describes movement along the line. Well, actually, b is not that difficult to work out. It is, in fact, the gradient of this line. For every one I go across, I go down 2. How do I know that? If I rearrange this to say y equals 10 minus 2x, the gradient is negative 2. So for every one I go across, I go down 2. So this is the vector this is the vector that tells me the direction of that line. And I can just as easily go 2 and minus 4, or negative 1 and positive 2. All of those options will work. So the vector equation of the line then is r equals some point on the line. It doesn't matter which you choose. Your textbook chose this point, and that's perfectly good, plus some multiple of 1, negative 2. You can write that just as well in i's and j's. You can say r, or r equals 5i plus some multiple of I minus 2j. Okay, let's try b. Calculate the position vector when lambda equals 1. So all we have to do is put in 5, 0 plus 1 lot of 1, negative 2. Well, that has to be 5 plus 1 is 6, 0 take 2 is negative 2. Or if you prefer, you can do just the same thing here. I'm not going to write out the sum, it's exactly the same. It's going to end up as 6i minus 2j. Okay, let's try C. If the position vector is 0, 10, what was the value of lambda? So 0, 10 is 5, 0 plus lambda 1, negative 2. What can lambda be to make this work? Well, the best way to make sure you don't make silly mistakes is to solve both for the x-coordinate and the y-coordinate and make sure they're the same. So the top rows of these vectors tell me 0 equals 5 plus lambda, which suggests lambda is negative 5. And the bottom rows of these vectors tells me 10 equals negative 2 lambda, which tells me lambda is negative 5. Good, I got the same value both ways. Therefore, the value of lambda here must be negative 5. Now, there's another subtle point here. I could have chosen any point on that line, and I could have chosen an infinite number of multiples of this vector as my position vector, as my direction vector, which actually means there's an infinite number of possible equations to describe this line. So these questions that ask me for calculate position vector when lambda equals 1 is technically ambiguous. You can calculate the position vector when lambda equals 1 in your equation, but if I had chosen this point instead to start with, instead of this one, I'd have had a different equation. And for example, in C, my value of lambda would have been 0 if I had started with this as my initial point here. Just something to keep in mind.